What's up, YouTube? Dr. Kemp here, once again, also known as Hammond Doc. Today I want to spend some time talking about testing tubes. Now, when you have a tube, and of course that's what you use in the Leslie amplifiers, Leslie 122s, 147s, you use tubes. Unless you have a brand new tube out of the box, like this, you don't know what you have. If you have a vintage tube, you don't know whether it's good or how the level of the quality of the tube. And even if you have a new one, it's a new one can fail. So you need to have a way of testing or checking for the quality of the tube. You can't just look at a tube and determine the quality of it just by looking at it. Visual inspection doesn't tell you how good the tube is. I've seen tubes that looked perfect that were no good. They were useless. And I've seen tubes that if you shake them, you could hear rattling. But when you tested the tube, when I tested the tube, it was high quality functioning tube. So auditory inspection, visual inspection doesn't tell you the things that you need to know about a tube. Even because it comes out of a box, doesn't tell you that the tube is good. So what you need is a tube tester. So that's what I'm going to share with you today, is how I go about testing tubes. Now I'm going to show you the tube tester that I use. It's right here. My tube tester is a B&K solid state tube tester, model 747. Okay, 747. Open it up here. Have some very expensive tubes on my desk. And when you open it up, this is what it looks like. Okay. And what you see here is there's a manual. Okay. Let me move this lamp down where it still has light, provides light. Now we have the manual here. Pan up. And this manual allows you, this manual is a setup chart. Dynajet solid state, dynamic mutual conductance tube tester, model 747. This is the chart that tells you how to set up the tube tester. You have to set up the tube tester differently for each tube that you are dealing with. And the chart is organized with, starts off with an OZ4 here, but these numbers move on down. Starts with 1A3, and then 1B, and then it goes on to 1N, 2A, 2C, 3C, 3H. Here are the 4s, the 5s, 5A, 5B, 5E, 5H, 5J, on and on. Then you got the 6s. So it has a number, then a letter. Here are the 6s. Okay. And then you have, so these are, it starts out with the numbers with letters. Going here to the 12s. One of the popular tubes that we use with the Leslie amplifiers is the 12AU7. That's the 12AU7 right down here. It's the 12AU7 here. This is the 12AU7 line. Going on, there's some other tubes. These are the TV tubes, 16s and 19s and 35s. And then it gets into just the solid numbers, 5822s, and on down. '66 and so forth. Then you got, it tells you the foreign tubes and the American equivalents. And that's what these are. All right. Now, I'm going to show you how I test, and I have some tubes on my desk from a previous video that I was doing on tubes. So I have some 6550 tubes here. These are audio output tubes, 6550s. So we're going to test a 6550 so I can show you how I go about doing that using my tube tester. The first thing you have to do, the first thing I do, is I identify the number here in the chart. So I've already turned to it. Here it is. Let's see if I can pan into the number. There it is. You see the number 6550. And then there is a series of numbers as you go across the chart here. It tells me the heater number. This first line here, column, is the heater number. 6 is a 6. Tells me the sensitivity setting has to be on 52. And it tells me the socket that I will use is socket number 14. And then it tells me also the button that I'm going to use to test the quality of this tube is going to be test button number 1. Okay, so this tells me how to set up my meter in order to test a 6550 tube. So I'm going to follow this instruction or these directions, and before I turn anything on, I have it plugged up. Now I'm gonna turn the power on. Okay, and I'm gonna go by this, and here's the heater. The heater is right here. How do I know it's the heater? Because it says heater. See, right there it says heater. How did I turn it on? I just hit the power switch. There it is. Off. On. How do I know it's on? There's a red light here. So this switch switches. This will heat up the tube. Now the tube isn't in the socket yet, but I want to set it first. You don't want to just put a tube in a socket and this is not set right, because this can burn up the filaments in your tube. So you want to set the heater first. Then the next thing we do is we set the sensitivity level. This is the level. This is the sensitivity level here. Now according to the chart, the sensitivity level has to be on 52. So I will turn this until it gets to 52. Okay, that's 52. Then the next step is to place the 6550 tube into socket 14. Socket 14 is down here. It's down here. Okay? So I'm going to take the tube and I can put it right there. I'll spin it. I spin it because it has a little key on it. And I want it to match up into the hole there. And then I place it there. Okay? Now, how do I go about testing the tube? Well, there are several things that I want to do. Several tests that I want to make on this tube. So I'll give it a few seconds to warm up and get ready. The first test that I want to make on the tube, and anytime you're doing tube testing, the first test you want to do is the test for shorts. Now, if there is, you want to know if there is some disconnection inside of the tube. If the elements of the tube is disconnected in any kind of way and you get shorts and you begin to do testing of the tube, you can actually mess up your tube tester. And this is a very expensive instrument. You can't just go into your Walmart store or even your Radio Shack and pick up one of these. This is a vintage instrument and it's very costly, very expensive. You can find various types of tube testers on eBay. This particular tube tester, and I own two just like this, was given to me by my father. My father was a high school teacher in the 1970s. He retired in early 1980s after 33 years of teaching. He taught the radio and television electronics class at the high school that I attended, Hope County High School, Rayford, North Carolina. My father also owned Kemp's radio and TV service throughout most of my youth, throughout my life, from the mid-1960s until he retired from teaching school. He operated a radio television shop, and so he had one of these in his shop at school, and he also had another one in the shop at home. We had a building beside our house, and that was his TV shop. And I worked in that shop as a young boy up until the time that I left to go to college. I worked in the television shop with my father, and my job was testing tubes. Now, during that time, my dad had me using another tube tester, a different tube tester. Arrington, let me have the blue tube tester over there, so I can show them. Show everyone, yeah, the one that I used to use when I was coming up, because this was reserved for my father. He would use this, but my dad would give me hundreds of tubes to test, and I had to test them on this little unit here, and this was my B&K Model 606 Dynajet. This was my tube tester. This was my job in the TV shop. And what I do with this one, even today, is this is my field tube tester. When I go on jobs to churches, I take this tube tester with me to be able to test the tubes in the organ and in the Leslie tone cabinet. So I'm still using the instrument that I used in growing up. So this is mine. But because my dad gave me his tube testers, the big 747s are also mine as well. Because Dad doesn't do this work anymore. He's into real estate now, so he doesn't do this. So anyway, back to the testing of the tube. The tube is ready to be tested now. So the first thing we check for is for shorts. And here's the button for the shorts here. So you simply hold this button down for about 10 seconds or so, and you're looking for this little light here to light up. So I push it down. Okay, and some would say even tap the tube. Tap the tube. See if it shorts, or if the needle moves. The needle is not moving. I'm tapping the tube, and the needle is not moving, and it doesn't show any shorts there. So there's no shorts in this tube. That's the first test. The second test is called grid emission. And what that deals with is whether or not there is the chance of gas escaping inside of the tube. So I will then check for grid emission using the same procedure. In other words, I'll push this button down and look to see if the needle moves. And I don't see any movement if the needle, if it moves and it stays in the green, this green area here, it would still be okay. But if it moves over to the black where it says grid emission reject, then I would reject the tube. So you reject the tube if it is short. You don't go any further. You just pull if it's short. If there's a short in the tube, you pull the tube and you discard it. If the tube is leaking gas, you pull the tube and you discard. You do not continue with your test. But in this case, neither one of those occurred. There was no short and there was no leakage of gas. So therefore I will continue with my test. And now I will check the quality of the tube by pushing down number 1 and holding it. And when I do that, you can see that the needle moved. And I'll pan up closer so you can see where the needle is. Holding this down. The needle is showing and the needle, it goes, the range is from 0 to 120. Okay? And the needle is right at 78. Right at a 78. Okay? Now, while I'm holding this, another test that I can do. Now, some tubes require a second test. using test number 2 button. This is test number 1, and then there's a test number 2 button, but there is no second test for this. In other words, you're testing the whole tube in test number 1. Some tubes you can test 2 sides of the tube, and so you have to use 2 tests. But with the 6550, there's 1 test that tests the entire tube, and you do it that way. And now, as the test is getting warmer, it's heating up, it's getting better. So it's right at 79, right now. Okay? So now another test that we do, the final test that we do, is a test for the life of the tube. In other words, how much life is left in this tube. And to do that, I have a little button here called the life test that I'll push while I am depressing the test 1. Okay, so this, I'll push it over like this. That's how I'll push it over while I'm depressing test 1. So I have to do those at the same time. So what I'm going to do is I'm going to put the camera back on the needle, and we're going to do a life test of this tube. Okay. So let's see what we get. Here we go. When I push test 1, now it's up to 80. As this tube gets warmer, it's even better. So it's at 80 right now. Now we're going to check the life test. We want to, you see it? Went up to about 81%. 81% life left in this tube. Okay, still at about 80 there. And I do the life test, and I hold it for 10 seconds. So this tube still has plenty of life left in it. 82% of its life still left in this tube. Now, what you want to see in the life test is about the same number that you get for the quality. So getting an 82 on a test that's testing 80, that's fine. If the tube in the life test had been 25% less than the quality, 25%, here I am, let's come back to me, 25% less than the quality, then that would have told me that there is not much life left in that particular tube. So it's a tube that's relatively useless as far as having life available for usage. And that would be a tube that I would discard because it doesn't have much life left. It's just something for you to look at because it's not going to be very useful. So 25% less. And now that's easy to calculate. If you have, for example, I just showed you how to do an 80 out of your head. If you had an 80, 10% of 80 is 8. Another 10% is 8. That's 16. Half of 8 is 4. That's 4. So that's 20. So take 20 from 80, and that leaves you 60. So if this would have tested 60 on the life test, then I would have needed to discard it because it's 25% less life, 25% less than what should be expected in a good tube. Now, so in other words, it's still functioning, but it doesn't have very much life left in it. So if you start using it, it's not going to be a very reliable, very dependable tube. So it's not something that you would want to depend on if you're going to be doing live performances. You're going to use it in church. You're going to be using it on stage. That particular amplifier with that tube in it, you'd want to replace that tube before you start using it. Now, if you're going to just use it at home, in your living room, you use it every now and then, and you might leave that tube in there and let it and use it up until it doesn't work anymore for you. But that's how I would look at that, and that's how I would use it. Let's check one more tube. Let's check a brand new tube and see what happens with a brand new tube. We're gonna pull this one. This thing is hot. I have just ordered. Let me show you something else. Let me show you something else. Rather than testing another tube, I want to show you this gadget that I just got. It's really cool. It's really cool. It's an infrared thermometer. Infrared thermometer. And what this infrared thermometer does is it's like a radar. It's like a radar for speed, but it's a radar for heat. So I can point this at that tube, and it tells me how hot the tube is. Look at this. Isn't this cool? Let me pan up here. 165 degrees Fahrenheit. Can you see that? Let me change hands. Let me see if I can find it. Turn it this way. Here we go. There it is. 158 degrees, 163, 162 to 163 degrees, 160 degrees Fahrenheit. That's how hot that tube is. Isn't that cool? You can buy these off the internet. This particular model is the 62, the Fluke 62 Mini. They run for brand new over $100. You can buy them off of eBay. You can check eBay and you can see them and find them there. And you can buy them much cheaper than I bought this one used because I don't use it that often, and I was able to pick this one up off of eBay for $40 bucks. So that was a great buy. If you can find one of these for $40, and I like it. I'm glad I have it. Why do I use it? Because what I use it for is that sometimes on an amplifier, I've seen one tube bright red and the other tube not be bright red like that, and so something's going on because you got two different levels of heat. Is it the tube, something wrong with the tube, or is it something wrong underneath where that tube is? And so this thermometer allows you to look at the heat for both of those that is being generated in both of those tubes, and to see if there is a significant difference in the level of heat coming from those tubes, and then begin to diagnose whether it's a tube problem or a problem somewhere in the amplifier itself. So a cool gadget, a cool toy that's now part of the equipment here at Vintage B3 Organ Incorporated. So you can still have fun and be an adult. especially when you get cool toys like this. Hammond Doc here saying, peace out.